Welcome to another video from Watchman. Today I want to talk about the rise of the Internet of Things, IoT, and the risk that it's creating in a uber interconnected world. So it's probably worth starting with just talking about what exactly is IoT, Internet of Things device. So simply an IoT device is any kind of piece of hardware such as a sensor or a gadget or appliance, machine, smart home device, whatever, that's programmed to carry out certain applications and can transmit data over the internet or some kind of network. Networked together, these form what has become known as the Internet of Things. Billions of small, often cheap devices talking to each other and to computer systems and relaying data, information, and sending commands. IoT devices today include everything from automated home heating systems to video doorbells to smart TVs and fridges. And they are, generally speaking, for the most part, essentially mini computers in their own right, running a cut down, reduced power operating system and small applications. So these things are globally connected. What does that really mean? Well, firstly, the number of connected devices now in operation around the world is truly and staggeringly mind-boggling. The number of IoT devices, at least considered to be in operation worldwide in 2021, exceeds 20 billion devices. So about around 3 billion of those devices are consumer devices. So that's smart devices in our homes, wearable technologies, devices in our cars. They're kind of the Alexas and the Ring video doorbell devices, as well as kind of small consumer devices like robotic cleaning machines. Around 40% of the total number of devices are actually used in business and manufacturing. And that might be for controlling robotic equipment. It's used in the supply chain, like logistics, in warehouses, and used in kind of diagnostics and analytics. And that's in manufacturing, in highways, systems, in bridges, etc. Kind of infrastructure devices. And then another 30% of the total of IoT devices are in the healthcare industry. So clearly, there are massive benefits to all these. Smart cities, smart homes, smart cars, telehealth, farming, factories, nanosensors. The benefits are pretty clear. So, in farming, eco-friendly, efficient farming using robots and IoT devices, devices in smart homes that help us to conserve power, smart cars that, will help to reduce traffic congestion, help to improve car efficiency. There are clearly a huge number of benefits to all of this. The opportunities are vast, but what about the risks? So first of all, are the risks real? Well, I think it's a universal axiom that it's in the nature of technology that if there is a way to exploit something for illegal purposes or to make money, then someone's going to do it. And in the case of IoT devices, there's probably three statements we can make to assess the problem here, the risk. One is the sheer size of the problem. The fact that the Internet of Things and the Internet in general has grown exponentially as a result of the widespread use of these devices, to the point at which the Internet is virtually unmanageable because of the sheer number of volume of devices out there talking to each other. There's also the question that there's a hugely disjointed landscape. There are tens of thousands of suppliers and manufacturers, hundreds of thousands of different devices, all with different standards applied to them, all different manufacturers, platforms, different software, different hardware. Then the second point is the nature of the landscape. By their very nature, IoT devices are kind of cut down, miniaturized devices, miniaturized computers. They have limited management capabilities, and they're often produced very cheaply, so they have limited resources. And one of the things that we continually say at Watchman is that reliability and security go hand in hand. And something that's made cheaply, that's made with very limited amount of memory, very limited processing power, is by its nature less reliable and therefore less secure. And in fact, that's demonstrated by the fact that almost every device that's been tested has got identifiable security flaws. Then the third point is another term that we've coined, the octopus effect. And that's put simply the fact that IoT devices are everywhere, from medical equipment to, yes, sex toys. And they're a prime target. They're a doorway into your home, into the workplace, into the car. They provide access across the internet to hackers, to kind of intimate areas of our lives that previously were not really accessible. So what's the potential threat? Well, really boils down to two primary areas, two primary things that hackers look to exploit if they can with IoT devices. And those break down to something that's called Trojan horses and hijacking. So Trojan horses is where hackers attack a device, exploit a vulnerability in a device in order to take it over. And what they want to do is use its computing power and connectivity to do something other than the device was originally intended for. So they're not actually interested in the device per se. They're interested in using its computing power to do something else. And this is generally called turning these things into zombies. So getting hold of a group, a network of IoT devices, hacking them, taking them over, and then using them to do something else with. So using them as a gateway to attack other infrastructure, to make something called a DDoS attack. It's a distributed denial of service attack. It's basically using a mass of these devices to attack another system and bring it down short by the sheer volume of the number of connections that they attempt to make. There's also more recently, since it's the flavor of the month, cryptocurrency mining. So that's taking over a group of devices and then using those instead of the intention they were meant to be used for, using them to mine for cryptocurrency, Bitcoin or Litecoin or whatever. The second threat to these devices is hijacking. That's where an attacker takes control of the device and wants to use the inherent functionality it's got. Now, that's typically devices that have the capacity and the capability to record audio and video. So, and that's classic. That's spying. You know, you hear stories all over the internet about people who've discovered that their home camera is being used by somebody else to spy on them. So it could be voyeurism, or it could be for financial or commercial or industrial fraud. So that's the kind of principally what the threats are, and then let's look at a couple of case studies just to put this in context. So case study number one is Mirai botnets. So Mirai is a virus that was discovered in about 2015-16, and it's a virus that's designed to take over devices that were insecure and then use them as zombies to attack other things. And the classical main ingress into those devices wasn't some sophisticated Hollywood hack. It was simply by finding those devices and then working out which ones of those devices came with factory default usernames and passwords. Admin, password one, whatever. There are a couple of major attacks. In one, 30,000 Wi-Fi cameras were used, taken over and used in the attack. In another one, 900,000 routers were infected at Deutsche Telekom and then used to attack other sites and other services. And there were some really significant impacts. So there were outages in 2016, 17, 18 to PayPal, to Twitter, to Amazon, to Netflix from attacks by these botnet networks of IoT devices. And which the costs and the damage that was caused really hard to determine, but certainly ran into the billions. So what could or what should have been done? Well, the industry could have moved pretty quickly. They could have recalled, the manufacturers could have recalled devices that were known to be compromised. They could have made a concerted effort to track down infected devices and disable malware. They certainly could have done more to raise international awareness at the need to create secure devices, and they could have imposed standards on the industry or attempted to impose standards around security settings to ensure that devices just never went out of factories with these kind of crazy standard admin passwords. And there could have been more effort to develop tools to sniff out attacks and to find compromised equipment. So that's what could have been done. What actually happened was none of the above. So Mirai, as I said, was first identified in 2016. In 2018, there was an attack on ABN AMRO Dutch Bank. 2017, 18, 19, there were a series of follow-on attacks to various different companies, exploiting various different, very similar flaws, just exploiting the default username and passwords to get into these devices. 2020 and 2021, indeed, Mirai botnets remain active in the wild. They are still out there. They're still active. They're still doing their stuff. And IoT devices are still being produced and manufactured that come with default passwords and even more critically, with and deliberately patching disabled. So manufacturers who are creating cheap IoT devices are making them such a way that they can't even be updated to protect themselves. Case study 2, Silex. So this was a malware targeting IoT devices, and it was actually the intent here was just simply to commit vandalism. It uses the same kind of exploits as Mirai, so finding default insecure passwords on devices. And then Silex, interestingly, was designed to actually just attack the device and effectively destroy it, shut the device down. In many cases, most of the users whose devices would have been attacked by Silex would not have realized it and maybe would have just simply assumed that their device had died of hardware failure or had gone wrong in some way, and effectively probably just thrown them in the bin without even thinking. The impact was a lot smaller, partly because the malware was only run for a couple of days, but it affected at least 4,000 IoT devices and bricked them. So that term means to sort of destroy them or damage them to the point where they're no longer viably usable. So about 4,000 devices were bricked before the 14-year-old creator of the malware shut down the attack himself voluntarily, basically on the basis that he hadn't anticipated how successful he would be or how famous or infamous he would become by doing it. What was the response? Well, tumbleweed. Again, almost nothing was done by the industry, by business to respond to this. And the only real response was from Light Lifon, which was the pseudonym of the 14-year-old hacker, who promised in an interview that he would develop a better version of Silex at some point in the future. So what does this mean and what should be done? Well, classically, there are really 3 steps that can be carried out here: education, legislation, and standards. Education. So one particular route is to educate end users and consumers on the need to secure their own devices. Well, this in principle sounds like it might make sense, but in reality, do we really think that non-technical or even frankly technical people like myself, end consumers, are really going to spend time and effort to reset the passwords and usernames of the devices that they bring home from the store? You buy something from the electrical store, are you really going to take it home and the first thing you're going to do is reset the password and username and check that the device is secure? Even if consumers do, is there really much hope that a majority of them aren't going to simply change the passwords to something that's easy to guess? Because who really at the end of the day, wants to be managing 20 or 30 devices with secure and complex and hard to remember passwords and usernames. What could be done in terms of education is education developers and the manufacturers to ensure a broader awareness of secure coding and securing by design. The only problem with that is that, of course, IoT devices are being manufactured and sold in a competitive market. Secure coding practices and policies and the secure by design processes cost money to implement and add to the end cost of the devices. And so if you are an entrepreneur who's attempting to launch the next, smart home trainer bicycle or electronic scooter or IoT device connected massage machine or weight loss device or therapy system, are you really going to be focused on security and accepting the additional cost when your competitors can produce a product that looks just as good as yours but is cheaper because they've shortcutted on security? Legislation. Well, legislation would be good, but again, it's a really patchy environment. California leads the way with having an IoT security law. And the European Union is attempting to do something similar. But the problem with legislation is that there is a lack of coordinated global law enforcement. There's really no effective way to manage all of the countries where those devices are being manufactured, many of them being manufactured in Asia. So they're not really affected by these laws. It's difficult to enforce those laws, particularly on the devices that are already in existence. What about security standards? Well, again, there's just no global entity or consensus to define IoT security standards. There are a number of security standards exist. There's some positive development in, for example, in the automotive sector, where the concept of IoT-enabled smart cars that could be hacked and driven into a tree or driven into a crowd or whatever is a pretty scary concept. You'd hope that the automotive sector takes this a little bit more seriously. But again, there's still a struggle when the fact is that the manufacturers are outside of these standards. And it's very difficult, again, to retrospectively apply security standards to the 20 billion, 25 billion, whatever devices that already exist out there in the wild. So what are the prospects? Well, frankly, in many cases, cybersecurity systems and solutions on their own just can't keep pace with the rate of growth and complexity. When there are reliable manufacturers that are creating security patches for devices, the problem is that the end users, the consumers who've got these devices, are just not going to have the skills or indeed the incentives to update. And many of the manufacturers of low-end devices just don't offer any kind of support or maintenance of any kind at all. And there's really no way to globally decommission the 20 billion or however many older devices out there already, including the ones that we know for definite are insecure, vulnerable, or even already infected. And testing has shown that at least 70% of the devices on the market right now are extremely vulnerable to attack. So the prospects are pretty scary. There are real-world examples of hackers shutting down electrical grids. There's the latest one in the news of the attack on a water treatment plant in the US. They've been used for domestic spying, hacking hospital equipment, turning off building heating systems. That was a classic. Some hackers, some comic hackers in Sweden accessed the IoT devices for a residential block heating system and turned off all the heating systems in the middle of winter, which can't have been any fun for the several hundred people who lived in the buildings. However, to date, thankfully, there have been no attributable deaths or injuries caused by hacks to IoT devices. But that sentence ends with yet. So I hope that's not going to keep you up at night worrying. But what can be done? We're certainly looking at Watchman and what Watchman can do to help. We've been conducting research on IoT devices and specifically on robotics, where we see the industrial robotics and co-robotics, where human workers, working alongside large, heavy, powerful industrial robots. So we've been looking at those sort of vulnerabilities for the last 2 years, and we've demonstrated that robotics equipment can be hacked into quite simply, and things like security protocols, safety protocols can be overcome. What we are looking at doing is Watchman's phase 3 of product development. We're looking to try and develop and release specialized lightweight agents targeted at low power, low resource devices like IoT platforms. And it is possible to monitor at least some of the devices at a low level for clear and obvious flaws and weaknesses. But ultimately, actually, it takes a coordinated effort, and it requires manufacturers to be on board and either willing to address security concerns directly, or potentially, for example, to ship their products with something like Watchman security and reliability agents built into them, so that they can be monitored securely out in the field. But getting them to integrate their systems with the universal monitoring product is going to be difficult, particularly because that, of course, carries cost. So, thank you very much for listening. I hope this doesn't keep you awake. It's there is more to do. Hopefully, the environment will change over time. I think people's awareness is much greater now. But thank you very much for listening, and have a good day.